All right, to this point, we've covered some new vocabulary words for Unit 4. We've talked about what it means to be a relation, which is just another way to express a list of ordered pairs. And then we can sort of break that list into two parts: the x values, which make up the domain, and the y values, which make up the range. And we're going to use all of those same words again, but we're going to use them to describe a new vocabulary word, and it answers the top of the page there that says, what is a function? So that's our new vocabulary word for today, a function. And again, we're going to reuse those same other words from before. So a function is actually a very specific type of relation. So let's keep in mind, what is a relation again? It's a list of ordered pairs. So you're going to see that everything you're going to look at today still involves these xy pairs, but it has a special characteristic, functions. It can't just have any random arrangement, but it has to follow this very special rule, and here it is. It says it's a special type of relation in which the members, or the values of the domain. What are the domain values again? That's the x values, right? So in other words, the x values are paired to exactly one. Maybe you want to underline that. They're paired to exactly one member of the range. What does it mean to be the range? It's the y values. So when you read that again, one member, or each member of the domain is paired to exactly one member of the range. What is that basically saying? It's telling us that the x values can only occur one time, or in other words, they do not repeat. In our silly example with the celebrities on the previous page, we kind of use this cheating reference idea. And so that's sort of what's happening here. If you want to think of this as like a relationship, the x values need to keep the relationship functioning by only being paired to exactly one y value. As soon as the x value starts cheating, or in this case repeating, then that's where you have a problem, and that relationship no longer functions. So you're kind of, think of yourself as a detective or investigator looking to see if every x value is being faithful. As soon as you see an x value being paired to more than one y value, then you're going to call that out and realize that it's no longer a function. I think it helps as we do these first couple examples. Let's just list the domain and range first as a review, and then we'll go ahead and answer the question whether or not it would be a function. So in number one, the domain falls under the x value, so we'll put the braces first. And as I begin listing them, I make sure we put them in order from least to greatest. -4, and this kind of helps answer the next question here for whether it's a function, but there's two of them there. We only have to list it one time. And then I'll say 0 and 7 and close the braces. For the range, we list them in order again from least to greatest: 2, 5, 6, and 10. And now we can go back and ask the question, is this relation a function? Well, what does it mean to be a function? It means the x values can only be paired one time to one other y value. And if I look at the x values right here in this list, I notice that 4 is mapped to 2, sorry, -4, but -4 is also mapped to 5. So that's like a Brad Pitt scenario where there's more than one y value that the -4 is being paired to. So is this a very good functioning relationship? No, it is not. How would you explain that? You could just simply say or maybe not even say you can just say -4 is paired to 2 and 5. Another way of saying it is one of the x values repeats, which I can use that in part of my explanation again for a different example, just to kind of show you the different ways you can explain this. But number one is not a function because -4 repeats. How about number two? It's a different format. There are lists of ordered pairs, but we can still look at the domain and range. Let's see, we have 8, -1, 14, and 5. So we'll put those in order. I like to underline them sometimes to show which numbers I'm exactly looking for. And then the range, 3, 1, 3, 26. So 1, only 3 has to be listed once. And there's my braces again. And I again come back to the question, is this relation a function? So be careful here. Which ones are we focusing on, the domain or the range? If you go back to the definition of a function, it's the domain values that have to be paired one time. So ask yourself, is 8 being paired more than once? Nope, it's being paired just to 3. -1 is also being paired one time to +1. 14 is also being paired one time. Now it happens to also be to another 3. So there's a little bit of a conflict there. You might say in a joking way it's like 8 and 14 are competing for the same y value. But they're both of the x values are still only being paired one time. So that's actually still under the good characteristics of a function. And the last one, 5, is also being paired one time. So none of the x values are repeating, so that makes it a function. You could say yes, and you could say no x values repeat. So that's the first two examples, looking again as kind of this investigatory idea here. You're looking for just the x's right now and deciding, are the x values occurring one time or are the x values repeating? Let's take a look at the last two examples. And here it's a mapping in number 3. And you can try to begin to tell if it's a function by looking at how many arrows are being branched out of every number in the x's. So look at 4. 4 is being paired one time to 5. It's almost like giving this the ordered pair 4, 5. -2 is being paired to 1, so our ordered pair would be -2, 1. 5 is being paired to 6, so we can say 5, 6. And 0 is being paired to 2, so we can call that point 0, 2. Do any of these x values repeat? In fact, maybe we should list them first in order from least to greatest to give us the domain. In the range, we have 1, 2, 5, and 6. Go back to the question now, is this a function? I'm only looking at the x values and seeing, do any of the x values repeat? And since each arrow is occurring one time from each number, it's not being branched more than once, we can say yes. I'll change the way I'll explain it. You could say none of the x values repeat, or you could say something like each x value is paired one time. Some kind of explanation like that is fine. There's no exact way to explain it as long as it includes one of those kind of variations. All right, good. Last one is a graph, and there's a list of, or actually a series of points. Each one has an xy pair to it, and we're going to list those domain and range values right now. One way I recommend doing that is to go ahead and actually label each point. So this point I put right here is going on the x-axis, I'm going over 4. On the y-axis, I'm up 3. The next point is the point 3, 2. Hopefully you can do this ahead of me as I'm kind of walking through this, see if you can figure them out before I can. On the x-axis, I'm now going over 2 and up 1. This is the point on the x-axis, so all I'm doing is going over 1, but I'm not going anywhere up or down. So that'd be the point 1, 0. Down here, as I begin to go into the fourth quadrant, I'm going over 2 again. This time I'm going down to -1. Then over here I have +3 and down to -2. And then finally to +4, but down to -3. So as I list my domain and range, I'm looking first at my x values. And I find it easiest to move from left to right when I go across this page to find which ones are my smallest numbers. So my smallest x value is 1, my next biggest x value is 2, followed by 3, and then finally 4. Again, I'm looking at just the first number in every ordered pair to make up my domain. Then I go to my second number in every ordered pair to find the range. But again, I need to list them in order. So my lowest y value, when I kind of scan from up to the bottom to the top, I'm looking at -3 as my lowest y value. then -2, then -1, then 0, then +1, +2, and +3. So there's a longer list there. So is this a function? Well, if I look at every ordered pair, I'm trying to find out if there are any x values that repeat. And I actually find that happen a couple of times. Here is a 2 that repeats, here and here. There's a 3 that repeats, and right there is a 4 that repeats. It's being paired to the positive version of a number and the negative version. So for many reasons here, there are multiple x values. You might jokingly say there are multiple affairs going on. There's 2 is dating more than one y value, 3 is dating more than one y value, 4 is dating more than one y value. So in many cases here, it's not a function because multiple x values repeat. Now, all you need is 1 to not work, but in this case, there is more than 1. And that's the idea behind this concept, is listing the domain and range again for review, but looking to see, do any of the members of the domain, do any of those values happen to occur more than once? If they do, it's a cheating situation here. You're repeating, and therefore it no longer acts as a function. So your goal then is to turn to the next example, the next list, and see if you can figure out which ones would be functions and which ones would not.